on our last unit of geometry, and we are into solids finally. Excuse my dog who's whining because he wants me to play with him. I'm hoping he doesn't annoy too much in the video. So this whole year so far, we've talked about two-dimensional shapes. Now we're talking about three-dimensional shapes. These are going to be solids. So there's different types. This first lesson is not hard, but there's three different chunks of it we're going to do. Shush, pager. So again, I'm going to recommend, especially for the three-dimensional shapes, you don't necessarily have to draw them. They're difficult to draw. It takes practice. Just have the definition written down. If you would like to take a picture with your phone maybe of the pictures, you can do that to reference later. Because again, part of this assignment, Major, is going to be identifying, Major, leave it, go lay down. Part of this assignment is going to be identifying these shapes. Okay, so let's start with prisms. So again, at the very least, you want to have the definition written down. Don't need to draw the picture though, they're complicated. So a prism has rectangles as their sides, but they are named by the shapes of their two bases. So these are all examples of prisms. Notice that they have two shapes that are the same. These are called the bases, the kind of highlighted ones here. These bases are triangles. These bases are also rectangles. These bases are pentagons, and these bases are hexagons. So we name them by those bases. If I saw this, I'd go, oh, this is a triangular prism because I see two triangles as bases, and the rest of the sides are rectangles. This is a pentagonal prism because I have two bases that are pentagons, and the rest of the sides are rectangles. So that's how we can identify a prism. If it's mostly made up of rectangles as its sides, it's a prism. Little hint there. Hey, this is mostly rectangles. It's a prism. Now we also have what's called a pyramid though. So a pyramid, they actually have triangles as their sides. Obviously we've seen the Great Pyramids before. They have those triangles coming up to a point, and they are named by their one base. So the difference here is that they all only have one base. This is a triangular base, so this is a triangular pyramid. This is like the Great Pyramids. They have a rectangle as their base. We have a pentagonal pyramid and a hexagonal pyramid. These are just examples. Obviously, there are other shapes that we can make pyramids out of. The key point here is, again, mostly triangle sides, it's a pyramid. Also, if it comes to a point like this, that's kind of your hint that this is a pyramid and not a prism. Notice the difference. We don't really have any of these coming to a point. Even the triangular prism doesn't come to a point the same way that the pyramid does. So cylinder, next thing, a cylinder has two circles at its bases, and this is actually a rectangle. If you guys didn't realize that, you probably actually did, if you never thought about it. We know that we can take a rectangle and make, this paper all crumpled up by my dogs, and make a cylinder out of it. This is a terrible cylinder. By curving it together, right? That's a cylinder, a rough cylinder. But it was a rectangle, yeah, and we curled it together. So it actually has two circles on the ends, and then that's actually a rectangle wrapping around. Cone, we know what a cone looks like. A cone has one circle as its base, and it's actually a portion of a circle as its sides. It's not super necessary that you know that, but if we were to like cut this open and lay it flat, like if you've ever had a snow cone wrapper and you've like opened it up, the sides here, it's not actually a complete circle, it's actually a portion of a circle. So it's only like that much. And then we have the circle as its base. Last one, if you want to write this definition, you can, but we can all identify a sphere. This is just the fancy definition, so I recommend write it down because they might reference it later. A collection of points that are the same distance from a central point in 3 dimensions. So this just means we have a center point here, and there's a bunch of points I could like shoot out from the center that are all the same distance away. That creates this sphere. Again, we know what a sphere looks like. The key thing here is really, guys, to prism and pyramid, we get mixed up a lot. And these are easy questions. Again, this assignment is going to be, what is this shape? Be careful with the prism and pyramid, the difference between those. Everything else, though, we know what a cylinder looks like. We know what a cone looks like. So those ones are simpler. Let's move on to part 2 of this lesson. So the next part we're going to look at is what's called a cross section. So a cross section is created by slicing a solid, which creates, if we were to slice the solid and then like turn it towards us, it creates a 2-dimensional face, a new face. We're going to watch this video because it gives some really good visuals for how this actually works. I will warn you guys, in this unit, the hardest part is visualization. These are 3-dimensional objects drawn on a flat surface, a 2-dimensional object. So it's really hard, and you may have already been struggling with looking at these pictures and realizing what's going on here. It's really hard to draw 3 dimensions on a flat surface. So this video, again, gives a really good visual of how this works.
Dimensional figures results in different 2-dimensional shapes.
So I hope that helped kind of visualize what's going on here when we're talking about cross sections. It was really important to try and just visualize this like you're slicing something, then taking that shape out and looking at it. So looking at this picture here, this is kind of how the picture is going to be given to you. What is the shape of this cross section? Once again, I don't recommend you draw this. You can maybe take a picture with your phone if you want to, but here's our cross section that we're looking at. If you can see that there, yeah, they kind of highlight it. Now looking at it like this, obviously, it doesn't look like a perfect circle. However, it is sliced. If you look at this, it is sliced parallel to the base. It'd be like I took this water bottle and cut it flat, right? I'm not cutting at an angle. What do we think this might produce? Take a guess. This is actually a circle. They did show that example in the video. That's because it's parallel to the bottom. If the bottom is a circle and I'm cutting parallel to the bottom, I'm going to create a circle as well. So cutting parallel to the base creates the same shape as the base, and this is actually a circle. Let's look at this one now. So let's find our cross section here. Here's my plane cutting through. This shape is a cone. So here's my cross section, and it can kind of help to kind of follow it with your fingers. What shape is that? That's a triangle. Even though we have this cone, which is a circular shape, if I were to slice the cone, we actually end up with a triangle as our cross section. Again, if you can imagine playing with Play-Doh and having a cone, slicing it off, and then turning and looking at that shape where you cut it, you would see a triangle. Now this last one, sometimes we have some angled slices, so we have to be careful with this. Notice now I've cut kind of sideways. There's my cross section. It's not parallel to the base, right? The base was here and I cut this way. What's going to happen is it creates this new type of shape you may not have heard of. You might call it an oval. In math, we call it an ellipse. So make sure you have this written down. If we cut a cylinder like that angled, it creates special shapes. Again, in the video, we saw that in a pyramid, in a rectangular pyramid, I think it was. Yeah. We got a trapezoid slicing sideways. So cutting, again, parallel or perpendicular usually creates like the basic shapes, like a circle, a triangle, a square, a rectangle. If we cut angled, it starts to create these special shapes. So again, an ellipse is the same thing as an oval We just call it an ellipse in math. So if we were to take this off, it wouldn't be a perfect circle. It would be kind of, again, flattened out because we're cutting it this way instead of flat on. So that's it for cross sections. You just have to be able to visualize, okay, if I were to slice this shape, what two-dimensional shape would I now see? Let's move on to our last chunk. So this is the last piece here for this lesson. We're talking about solids of rotation. So what this means is we can create a 3D solid by rotating a 2D shape, once again, a paper, two-dimensional, my water bottle, three-dimensional, right, through a certain axis. So this is an example. If you've ever seen these party decorations, if you've ever helped your parents getting decorated for a party, you probably have. A lot of you guys have huge families and you guys throw parties all the time. You might have seen decorations like this at the party store, but you can actually make them yourself. So what you do is you take tissue paper and you kind of cut a single shape. This is a two-dimensional because it's flat, right? 2Ds are flat. And you kind of stack the tissue paper up so that it stacks on each other in this two-dimensional shape. What happens is then you open it up and kind of go all the way around, and then you staple the two ends together. So I have a bunch of tissue paper kind of stacked. I go, whoa, and then glue them together to make this three-dimensional shape. So same thing here. This is the two-dimensional shape, but it's a bunch of tissue paper stacked up. You open it up and then glue it together, and now you have a three-dimensional shape. So this is an example of what we call, again, solids of rotation. We are going to rotate a 2D object, and we have to be able to visualize. Like I said, this is the hard part, the visualization. Have to visualize what shape will be created. So let's look at this first example. So it's important to note the axis of rotation. We're rotating it here. So we have to be able to imagine, I start off with a rectangle, right? And I'm going to spin this rectangle through this center. So this is like taking the paper and holding it at the center and rotating it, yeah? Now, if you can imagine that my rectangle leaves a path. Like if I were going to be rotating this in Jell-O, and this was a very hard piece of paper that didn't fall to the Jell-O, right? You want to imagine scraping away all that Jell-O. What shape would be left? What shape hole did I leave? So think about that for a sec. You can write down your answer if you think you know. If you could draw this picture's not too bad. Let's try and imagine this. So here's what's happening. My rectangle, again, is rotating and leaving a path. Hopefully you guessed that this was actually going to create a cylinder. This is a cylinder shape. Again, I'm starting with a rectangle, but notice that it cuts a curved path as it rotates, right? That paper is cutting a curved path, which results in a cylinder. So that's actually what this would create if we rotated it about here. Now, if I rotated it about here, just as an example, this is a different axis, yeah? I'm actually still creating a cylinder, but it's just going to be a wider cylinder, yeah, as opposed to rotating it about its center. So that's what this is talking about here, that this line is where we are rotating it from. Now that's important for our next question here. Now I don't have a triangle, but I suppose I could make one real quickly. Let's see. Gotta cut this out of the Edpuzzle. For any of you creeps who are watching this on YouTube for whatever reason. Okay, so here's my rectangle. And let's see, it's kind of set up that way, right? Or opposite, doesn't really matter. I'm rotating it about here. Now that's important because if I were to rotate it from the edge, I would get a different shape. Again, if you can imagine, rotating it about this way, that's going to create a different shape. Again, if I was rotating it from here, versus rotating it about this axis, yeah? So if you can imagine, I'm rotating it about this axis, imagine the shape that it is creating. If I were to stick this into Jell-O and go, what shape of a hole would I create in the Jell-O? What do you think? Make a prediction. Well, this is what's happening. It's rotating along this side and kind of cutting a curved edge this way. That creates what is the shape? A cone. Now again, if I were rotating it from right here, I would have a totally different shape. It'd almost be like a bowl, right? If I were rotating it from here, it's hard to do this. Yeah. I have kind of, again, this empty space in the center of that rotation versus creating a solid object altogether. So again, that axis is important. We can create different shapes by rotating it differently. The key part to this entire unit and this entire lesson, just to start off with, guys, is visualization. So we're going to come back together, practice this a couple times before you guys go do your assignment.